we are approaching a new digital revolution. More than half of the world's population has an internet connection, resulting in continuous streams of data generated by the technologies we use in our day-to-day lives. The Internet of Things is impacting virtually all stages of economy and social life, representing a profound change in how humans interact with machines, information, and even each other. The increasing maturity of big data, cloud solutions, and new internet-connected devices have created an exciting and valuable opportunity to build the next generation of data-driven smart solutions. Information coming from multiple sources must be accessible in real time, creating a digital continuum. Breaking down boundaries between domains will enable the exchange of relevant data across multiple applications, avoiding the current silos of information. FIWARE is driving the standards to make all this happen, unleashing the potential of real-time open data at a large scale. It simplifies IoT, allowing developers to merge IoT data with data from other relevant sources and get access to it using well-defined RESTful APIs, reducing both the time and cost of development for IoT-enabled smart solutions. Thanks to harmonized data models and APIs, developers are able to create applications that are truly interoperable. Real-time data exported in a city can be combined with data from vehicles acting as mobile sensors to enable new services and improve processes like predictive maintenance of fleets and roads. Systems associated to milling and coordinate measuring machines in a factory can exchange data in a trustworthy manner for a better performance. FIWARE ensures a sovereignty on data, allowing the appropriate levels of access to data to be defined, for instance, for potential monetization. Data from vehicles can be published on a data marketplace supported by the city, so it can be monetized when used by third-party developers. FIWARE Context Information Management is the basis for the new data economy and the creation of innovative business models in multi-sided markets. Join us to ensure that standards are driven by the needs of all society, and to ensure that FIWARE will stay free for all, forever.
So we are going to discuss about these four subjects in this starting event today. What is FIWARE and why FIWARE? For the enablers, I think it should be on the next section, and some use cases and a demonstration we will show you. Okay. So FIWARE is a project from. It was initially a 5PPP project. It was a public-private relationship, but it's a project from European Union, which is basically for the development of global deployment of internet application of the future. Okay, it's open, it's royalty free, okay, and it helps developers and providers and companies of other organizations to develop a project very fast and publish it. Publish the project. So it has a set of enablers and different kind of software middlewares that I will be discussing about in my presentation. So why FIWARE? So it provides you a full stack of generic, open and reusable components which are seamlessly connected with each other. It's royalty free, so you don't have to, let's say, you don't have to give any royalty, and it's all based on open standard. We have a large community of developers working on this. There is no vendor lock-in, so you don't have to get locked with particular vendor. You are flexible. You could change the vendor whenever you want. Of course, it's modular, scalable, and it's highly performant, which is you can find the performance test cases. So it's been continually tested, and it can also be plugged in with legacy system. So if you have a legacy system and if you like to plug in with FIWARE, you can do it. You can pretty much do it. There are ways I will tell you about it, how you can attach your legacy system with FIWARE. So some of the enablers of FIWARE are an Orient Context Broker. So this is one of the central blocks, and we will, during our next sessions, we will be talking a lot about it. Because this is the one which is managing the context information of a smart object. Now, when I say smart object, what do you think a smart object is? A smart object is something which is, let's say, is aware about itself and its surroundings. Okay. For instance, I have a pen here. It's a normal pen. I can write it, but it doesn't know about like its ink level or the temperature outside or humidity level. So it's not a smart pen. But once it knows about the attributes of like what is the ink level, what is the temperature outside the room, and humidity level, then it becomes a smart pen. Okay? So this is the definition. This is how we define a smart object. So Orient Context Broker, it's helpful for managing the context information. So when I say context, you can understand that a pen can be an entity, okay, and the ink level, the humidity, and let's say luminosity or whatever, the other attributes, they are attributes for it. So you can express pretty much everything in form of attributes and entities. Okay? Okay, then we have a lot of IoT agents. We have our in FIWARE we have a protocol called NGSI, okay? And it's similar to REST for the people who are familiar with REST. And the purpose of these IoT agents is to translate the because your IoT devices, they understand MQTT, co-op, and these kind of protocols. So IoT agents help to translate this different protocols into NGSI, because so that we can have a common kind of language being used everywhere else in the FIWARE platform. So IoT agents are installed more on the southbound side towards the sensor, so that the data can be translated and it can go to Context Broker, which is the first point. Then we have a CFIRS enabler, so for the edge level intelligence. So of course, when we have these sensors installed on several locations, you definitely need some kind of edge logic, because you cannot always be dependent on the cloud to operate everything. Sometimes maybe the cloud is not available, so the system should have some kind of edge intelligence. For instance, in agriculture, for automatic irrigation and this kind of system, for which we don't need to enable cloud. The CFIRS is one of the enablers for providing edge level intelligence. Then we have CCAN. So CCAN is quite a global standard now for managing the data catalogs. It's being used by most of the governments in the world, including for the data portal for UK, and one of the biggest portal, CCAN portal that we know is the European Data Portal.eu. It's the biggest one. So it is a enabler for managing the data catalogs, because once you gather a lot of data, or when you have a lot of open data, when the government needs to publish and they need the citizens to get access to that data, so you need some kind of enabler to do that. The CCAN is the one for the FIWARE. Then we have enabler for Cosmos Big Data, which is a big data generic enabler for FIWARE. It's a wrapper over Hadoop. Okay. Then we have Cygnus. Cygnus is a enabler based on Apache Flow. So it's a kind of a messenger that helps us to, let's say, transmit information from Context Broker to different kind of things. So we will discuss in detail Cygnus in our future presentation. Okay. So this is the overall architecture. So you can see the Context Broker sits in the middle. And on the top, on the bottom, you see the southbound part. So you see that there is a IoT agents there, which are interacting with actuators, IoT sensors, and so on. And these are sending the contextual information to Context Broker. And from there, the context broker only stores the current state of the system. So if the level of the ink in your pen is like at 5%, for instance, it will only store that information at that time. If you want historical information, for that you need some kind of more enablers like big data or short-time historical enabler for keeping the historic information. And as you can see that from where it goes to CCAM. So there is one more detailed model here, which is recently published on FIWARE. And you can see on the bottom, you see that there are, if I'm looking here, if you can see my cursor, so you can see that there are cameras and drones and everything. They are interacting with 1M, 2M, okay? And media processing Prento, it's also an enabler in FIWARE. So they are all interacting with either 1M platform or IoT agents in IDaaS NGSI agent framework. And from there, they go to context broker. As I told you already that the FIWARE is capable to interact with even the third parties. So you can see here that you can write an adapter for taking the inputs from social networks or any third party, CRM or anything. Third part is that you can see that if like there is a vertical solution and if it's already built up, and if there are if the sensor provider is providing some kind of an API, in that case also you'll be able to write a system adapter to adapt it for the NGSI. Okay. Now if I go a little bit further on the dark blue area here, then you can see. We have street, parking space, bus, waste bin, shared car, and civilian claim. So this is the part which within context broker it stores the contextual information, the current state of that smart object. Then after that, if I go top here, you have processing engines like Spark and Hadoop. So these are a part of Apache ecosystem for doing the processing. And analytics, on top of it. So on top of it, you will be able to make some complex event processing. You could run some big data event algorithms like map and reduce, and you could let's say get some aggregated information from the smart object, like from its history. Or of course, you could write some AI algorithm on top of it using this processing engine. And in parallel to that, you see there is a wire called Mashup. So it's an enabler for quickly creating some presentable materials and presentable GUI. Then there is a knowledge via in GIS. These are other kind of dashboards. They are tools for creating dashboards. Although in my presentation, we'll show you how to create dashboard from scratch using some web development tools. And if I go to on the right hand side here, you see QROC, authorized force and access control. So it's actually for providing authentication and authorization on FIWARE, because when you interact with this big stack, you need some kind of authentication and authorization also. And on the bottom part, it's a TM for Business Open API. So of course, FIWARE has an option for like if you're running a business with a partner, you could have TM forum standards for revenue sharing and like that. I think I talked about a lot of subjects at the same time. So do you have any question until now? You can ask from this architecture. I think this is going to come again and again in my next presentation. And of course, I will tell you again whenever it's required. Any question? Okay, so you can. We have a small group of people here, so you can block me anytime, and I can help you if you don't understand something. Okay. So as I told you, that context broker is storing the current state of a smart object. So there are two things. two kind of players here. One is the context producer, and second is context consumer. Okay. So the purpose of context consumer is to create the context information, like who is going to contribute it, let's say sensors or the third parties who are the context producers. And context consumers could be, let's say, Android app, which on which you're trying to see the state of a sensor, what is the temperature or humidity or so on. So those we call as context consumer. And of course, you have some kind of subscription mechanism. Let's say you are a context consumer and you would like to be updated when a state of the object is changed. Then you can have subscription. Okay? So I would discuss all these three parts in detail in my next presentations. Okay, so some more examples here. You can see that how you can express any smart object in form of entities and attributes. So you can see in case of smart cities, there are shops. So a shop can have a location, a business name, a franchise, and an offering. A bus can have a location, number of passenger, driver, a license plate, and so forth. A citizen can have a birthday, preferences, location, and to-do list. So as you can see here, in case of smart city or whatever attributes that you're looking for, some of the attributes are more static in nature and some of them are dynamic in nature. So for instance, location of a shop is of course quite static, but location of bus is quite dynamic. Okay? So these are the attributes that will change. So there are of course two kinds of attributes. Citizens can have birthday, preferences, location, to rules. Similar to that, smart agri. So crop, humidity, leaf area, age of the crop. A tractor can be expressed in a location, speed, and direction. A drone can be expressed by location, battery level, speed, and direction. In smart industry, you can see there is a gas tank. It could have a station, max volume, current level, minimum threshold, temperature, and so forth. A tanker could have a driver information, location information, the volume of where in each tank, the current level, speed, and direction. While a station could have a location, owner, and what's going to be the SLA for that. So I think the benefit that you get is from FIWARE is that once you make your software, it's very reusable, and you could reuse this. Once you make the solution for one city, you will be able to reuse it to another city very easily. Yes. So this will help us to create a very good data economy for the multi-site markets. So this is an example here. You can see on the top of on your slides. You can see there's a standard API where it's showing the state of this speak light. It's going to be on, it's or off. So it simply can be done by calling this V2 entities lamp on ATTR's power state value to 1 to switch it on. So the FIWARE, if you implement the architecture well, then this speak light would be on. So you don't have to worry about connectivity with your IoT devices, because once you step into the FIWARE, you write your adapter to the FIWARE, you would be able to get a lot of enablers, and you can create a lot of tools on top of it. So this is what I was saying, that once you agree with the context information I talked about, you can use a lot of other FIWARE enablers, software that you can use for developing your application. So I would be talking about some of the use cases. So in Silo, so this is one of the applications which is using FIWARE. On the right hand side, you can see the application snapshot as well. So in Silo is actually there was one of the problem. It's for the feeding of the cattle, and before they had to look into the silo, which is this big device, big container, as you can see, in which they were keeping the feeds for the cattle. And the problem was that every time, and it's really big, it's really huge one. And the problem was that every time someone has to go up and manually check what's the level of the silos. So the developers, they made a patented 3D scanning design to measure like what is the current state of using a camera, what is the current state of the silo, and the same is connected to the FIWARE platform. So and it's easy to install, so it can be, once we make a solution like this, you can easily distribute it to another customer whenever it's required. It's completely based on solar energy. Then there is another use case, a device for smart metering and quality of water monitoring. So this is one of the requirements where we had to provide a solution so that people can measure the level, if they are getting the proper water for providing the water monitoring, as well as to see the health of water, okay? The quality of water that they are getting, and they can install it in their home, so that the water municipalities can know that the quality of water is not good at particular place, because currently this is something which is manually checked. So this was implemented using FIWARE, using LoRa. LoRa, if anybody knows about LoRa. LoRa, anyone? So LoRa is, you know?
Just heard the name.
Okay, because I think you're working on IoT. So LoRa is the connectivity solution that we have for connecting those. It's a network actually. LoRa network for the devices to connect to the central controller. Okay.
I have a question. Just
Yeah.
here.
Yes.
Water quality monitoring. So what kind of sensors? So you monitor, because water quality, actually there may be a lot of parameters
Yes.
to measure to quantify the quality of the water. So what kind of sensors will be used? So you are not discussing about the sensors?
Yeah, I'm not discussing about the sensors because I'm focusing more on the FIWARE and that part of the question. Because I think I'm not quite sure about this part, but I think they partner it with some companies, because we have a lot of sensor providers which directly provide FIWARE interoperability. So like it's more like plug and play. So you can get the sensors directly from the manufacturer, and they are directly FIWARE compatible. So you don't have to write the extra part of the code, translate that to a FIWARE translate for the FIWARE platform. So right there. So we have a lot of manufacturers providing this solution. Yes, exactly. Okay. So now there is FireSonic for the detection of event detection and identification. So it uses 3D audio capture for measuring the sound, because I think it's a big problem in big cities to measure the level of sound, because it can get really noisy. So it uses this 3D audio captures to measure what is the amount of sound in decibels. You can see on the right hand side, you can see the level of sound at particular different regions in the city. It's over here, it's the application snapshot. So they're using this sensor, it's there, FireSonic. And you can get the monthly and daily reading for the statistics. So you can know that which part of the city is more noisy than the other, so that we can optimize the city accordingly. Okay, so this is another application. It's for the heart monitoring of the person who is driving. So it's actually more useful for the fleet management, because there are a lot of drivers and they drive back to back. And sometimes in India, at least, we know that there are drivers who are sometimes working for more than 21 hours. So it really becomes difficult. So we need So this is one of the solutions that they to see that if everything the driver is alert, or you can check the heart rate of the driver if he is alert and he's concentrating on his road, like that. So you can provide this kind of environment using FIWARE. Okay. And a small kettle wave, sensor wave, smart kettle wave. Yes, it's coming.
That's fine.
Okay.
Is it just collecting the data and alerting the driver, or also alerting somebody else?
Alerting somebody else, yes, definitely.
Hospital or doctor maybe?
No, not exactly, because this is something which is between the free management company and it's not about. I think it's more about the person is whether he's not sleeping or something like that.
Just
Also for the heart rate, for the heart also.
deep breath.
So I believe that this goes to the central command center, and from there they can get alerts to the appropriate authority, or of course we can customize when required to directly approach the authority. So it's up to you how you design the solution. So I'm just discussing about different use cases of FIWARE. It's all up to us that how we want to design our solutions.
How do you handle?
Yeah, exactly. So you can think of many ideas. So the idea of this making this presentation is to give you idea about FIWARE, so that you can think about yourself and how you can apply FIWARE and where you can apply it. And then we have a smart Caterpillar sensor wave. So, so what it does is that you can because there is a grazing, that you have to send your animals for grazing and all. So you can install exactly the sensors on top of the kettle, and then you can have the tracking of the animals, like wherever they are. So you just install I think it's a tag on each cow or cattle.
RFID tag.
Yeah, RFID tag, any kind of tag that you want, but you can, once you connect with the FIWARE platform, then you get access to analytics and all this. You get the whole stack by then. So you can see here, you can automate the tracking of individual animals. That will help us to prevent adverse conditions. So with the adverse condition, you can always let your cattle come in back, and you can get alerts for animal sickness and inventory. Okay, so I'm going to demonstrate an application which I made. I think we're about to reach. We just have 5 minutes now, so I will show you the demonstration of one of the applications that I made. So I'm just going to play the video here because that will be faster. So it's a smart city application, as you can see. So in the top, I'm going to tell you in fact about this application, how you can make an application like this in the presentation, including how you can put the markers on the map and so on. But as of now, you just see what you can create. So if I go further here, so you can this application has, for the world, you can see that we are collecting information from China, from India, and from France. Okay, so you can see that from different locations, you are able to see what is the current state of weather at a particular location. So as I was telling you, that FIWARE is very capable in in interfacing with a third party. So here you can see that the data is not coming from a sensor; it's coming from a third party. Here. Okay, and we're translating that data and making it adaptable for the FIWARE. So there is weather information here. Then you can see, if I move further, we have air quality information. So you can see air quality information from these regions, including what is the PM 2.5 level, particulate matter, sulfur dioxide level, all the harmful gas emissions, and so forth. Okay. After that, you also get access to the current live train running information, like where is your current train is, okay, at a particular point. Okay. So this is all we have done using FIWARE. You can also see the list of all the bus stops. So this is one of the city in France called Rennes. So in the REN you can see a list of all the bus stops here. Okay. And if I move further here, so here you can see the state of the bus stop and like the current location of the bus stop, what is the name of the bus stop. Okay. We have implemented live bus tracking. So this is the city of REN again, and you can see the live bus tracking going on here. So you can see the buses in 3 colors here. Okay, one is orange, one is like half black, half orange, and one is black. Okay, so you have defined different colors so that the user can identify from the color codes like what kind of bus it is. So the orange bus is the one which is, let's say, currently in service. The half black, half orange are currently, they are not in service. Okay, and for the completely black bus, we don't know the state of those buses. So let's see what would be more interesting is that if we you can first see the latitude and longitude location for the bus, and if I move further here. More depth of these black buses, you see a lot of bunch of black buses, black and orange buses standing there. And if I move further closely to that location, you can see that a bus shard on which the buses are standing. There you can see that you can easily see the current state of the bus, and they are currently standing in the shard because they are not in service. Okay. So you can, when you add these entities on a maps, you will find a lot of interesting information for the user. And I think after that, other than that, we have a cycle parking area. So we have many cities in France which have bicycle stands. So you can just pull on your bicycle and you can go to another location and you can. Put your bicycle there. So you can find the live state of that bicycle stand here. You can see that how many vehicles are currently available, how many stands are available. Do you have a parking for that or like that? How many bicycles are there? So you can have that access to that kind of information so that you can know in advance that where you can park your bicycle. I think that's the last entity which I have covered in this demonstration. So I am now moving to the questions. If any of you have any questions, please feel free to ask me. No matter what, so please ask your questions now.
Yes, my question is last application.
Yeah.
So you are showing bicycle or some bus or all these
Yes.
things. So these are live data.
Yes, these are live data.
So these things are implemented by some organization, and these are stored in the FIWARE, and you have the access right.
Okay, so it's more like because why we did this actually we made this demonstration for when we were working with GSMA, and we wanted to demonstrate the use of harmonized data models. Okay? So what we did is that we this is the data which is coming from, as an open data coming from different sources. So for the bicycle, I think if I go further here. If you see, there would be an attribute. Maybe I think I'll show you that. So there is an attribute on which you can see what is the provider for that data source. Okay. So it's not there in this one, but you can find that. Okay?
So actually, they permit you to use this data.
Yes.
You get permission.
Yeah. But of course, the purpose of showing you this demonstration is that once you have your own sensors and demo, you can plug it. And also you have a possibility to use this as a integrated with third parties. In case if the third party is let's say is not using FIWARE technologies, so you can always write a translator to translate his protocol to NGSI and make it compatible for FIWARE.
Why I ask this question is good because you see,
Oh, yeah,
when you actually do some simulation or other things, creating some simulated data and we experiment with this, and with the real data is far different. So if you have permission from real data, then you can do your experiment exactly. Or when you are developing something, if you get real-time data, it will be more valuable upon many.
Yeah, exactly. So this is all the data that we see is real time in nature.
Through FIWARE, we may get access this type of data.
Yeah, it's not through FIWARE actually. What we have written is what we call as NGSI translators. Okay, so I will show you a demonstration how to write one actually in my future presentation, that how you can write an NGSI translator of your own. So you translate that information which is coming from a third party, and you translate it and make it compatible with FIWARE, and then you can use the whole FIWARE bricks after that. It's like that.
Translation, that means from French to English, or
No. From one protocol to another, because let's say how they are going to store the information. They are going to store the information in their own way. So in FIWARE, you have some kind of standards. So we can convert them into harmonized data models. So because if one city uses one model and another city uses another model, it would be too difficult for the two cities to talk to each other. Yeah.
Thank you.
So any more questions, Professor Islam or anyone? Sorry, I'm going to stand. Any more questions, or you want me to go back to the slides or explain you something more? Okay.